All right, so let's play another game of Gauss-Jordan elimination. So just keep in mind that our goal is a matrix that looks like this. We want an augmented matrix that looks like this so that we can just read the x, y, and z values off for our solution. Right, so we have this goal matrix right here. This is our goal. This is our goal. And then just remember, too, the 3 different row operations that we can use, okay? And you can only use those 3. So let's start by writing the augmented matrix for the original set of equations. So this is equivalent to 0x plus 2y plus 3z equals 7. So the coefficient here is 0, and then the coefficient at y is 2 and 3, and then we have 7. All right, and the coefficients of the second equation, 3, 6, minus 12, negative 3, and 5, negative 2, 2, and negative 7. All right, now we're just going to start with the first column and try to transform this set of equations, or this augmented matrix, so that the first column has a 1 in the upper right-hand corner, or upper left-hand corner, and then zeros below. So how can we do that? Well, I had a 0 here, so I could. There's a number of different ways I could get a 1 up there, and probably the easiest way would be to swap rows. But then I could also see that the second row has a common factor of 3. So I'm thinking that the first thing I might try is just take 1/3 of row 2. Okay. And I'm not going to touch row 1 at all in this first step. And then I'm just going to divide all of these elements in the second row by 3. So I have 1, 2, negative 4, and negative 1. Or, yeah, negative 1. And then I'm not doing anything with the third row. So I'm just going to copy it down as is. Now I have a 1 in the first column, and if I just swap rows, I can bring that 1 up to the upper left-hand corner, right? So I think what my next step will be is to just swap rows 1 and 2. Row 1 and row 2. Okay. All right, so what do I get? When I do that, I'm just swapping the rows, right? So I'm gonna write row 2 for row 1. And then I'm going to put row 1 as row 2. Okay, and then I'm not touching row 3. So row 3 is just as it is. Negative 2, 2, and negative 7. All right, so now it's starting to look like the goal. Now I just need to get a 0 in row 3. And then I'll have the first column taken care of. So probably the easiest way to get a 0 in row 3 is to take row 3 and replace it with row 3 plus, well, let's do minus, right? Or plus a negative 5 times row 1. All right. So I'm not going to do anything with rows 1 and 2. And minus 1, 0, 2, 3, and 7. And then I'm going to make a little notes to myself. So if I multiply by negative 5, I get negative 5, negative 10. This becomes a positive 20, and this becomes a positive 5. So if I just add those values that I have in red to row 3, then I'll get my 0 where I want it. And then I get negative 2 plus a negative 10 becomes a negative 12. 2 plus 20 is 22. And then 5, or negative 7 plus 5 is a negative 2. All right. All right, so now I have the first column taken care of. I've got it the way I want it. So now I just need to go on to the next column. All right, so what can I do? So I want to make sure that you understand. I'm making decisions every time for each step of this. I'm making a decision. There are a number of things I could do for my next step, and there's more than one way to get the same answer. All right, there's one right answer essentially for this particular problem, but there's more than one way to get there. So what I know is that I want to get, in the second column, I want to get 0, 1, 0. So when I look at this, I'm thinking, well, I don't know. I can see that this last row, they're all even. So I could take, I'm just going to do that. I'm just going to take -1/2 times row 3. And I can just take that little baby step. Sometimes it's better to take baby steps just because then you're less likely to make mistakes. So I'm just going to take a little baby step. I'm only changing row 3, so I'm just going to copy down what I have for rows 1 and 2. Okay, and this is 2, 3, 7, and then if I take take -1/2 times everything, I get 6, and this becomes -11, and this becomes 1. All right. Now, I'm not seeing a real easy way to get a 1 in this first column, but I can see an easy way to zero out the numbers above and below that middle value, right? Because I want a 1 right here where this 2 is in the middle of the matrix. But if I divide everything by 2 at this point, then I have to deal with fractions. So I don't want to deal with fractions. That's just my preference. It would not be wrong to divide that second row by 2. But then you'd have to work with fractions, and I don't want to deal with it. So, but I can see that if I take row 1 and I subtract row 2, that's an easy way to get a 0 where I want it in the first row of second column, right? So if I do that, let's see, I'm going to take 1 minus 0, which is 1, 2 minus 2, which is 0, so that's what I was going for. -4 minus 3 is a -7. And then -1 minus 7 is a -8. Okay, so I'm just taking row 1 and subtracting row 2. That gives me a 0 where I want it. Now I can do another thing too. And I'm not going to touch row 2. But I need a 0 below that's in the third row, second column. I want a 0 there. And I know if I take -3 times the second row and then add it to the third row, then I can get a 0. So I'm going to make a little note. I'm going to take, actually, let's write down the row operation. I'm going to take row 3, and I'm going to add a -3 times row 2. So let's write down what that would look like. What is -3 times row 2? All right, so -3 times row 2, I take -3 times 0, I get 0. This becomes a -6, right? This becomes a -9, and this becomes a -21. Okay, so that's -3 times row 2, right? I could write a 0 here, but it's the same. Anything times 0 is 0. So, all right, so now let's do that. So this element is 0. I take 6 minus 6, and that's 0. That's what I was going for. And then I take -11 minus 9 is a -20. And then I have 1 plus a -21, which becomes like a -20 also. Okay, so there's my next augmented matrix. And I can see now an easy way to get a 1 in the lower right-hand corner where I want it, right? If I just take row 3 and divide by 20, right? So I'm just going to take, actually I'm going to take -1/20 of it. That way it'll be positive. All right, so let's do that. Now you can see I'm not quite done with column 2. I want a 1. I want a 1 in the middle, but I can't see a way to do that at this moment without getting fractions. I'm just going to leave it 2 for now. Okay, I'm just going to leave it as 2 for now. All right, so I'm just going to leave row 1 as is, and row 2, I'm not touching that at this point, and I'm just taking negative 1/20th of row 3, 0, 0, 1, 1. Okay, so now you can see the solution for z, right? Z is equal to 1. If I turn this back into a set of equations, this is equivalent to saying this last row is equivalent to saying z is equal to 1. All right, so I'm going to leave that 2 as it is. All right, I'm just going to leave it alone because I don't want to deal with fractions. And we'll see what happens. We can maybe deal with it at the end. Because now I'm going to go ahead and work on the third column. And I want the third column to be a 0, and then a 1. And so I'm going to use the last row to zero out the columns, the values in the columns above. All right, so I'm going to take row 1, and I'm going to add 7 times row 3. Right, so what's that going to look like? If I make my little notes, this is just going to be 7, and this is going to be 7. I'm just going to add that to row 1. All right, so, and of course these zeros are still 0, so I have 1, 0, so it's not going to change anything in the first 2 columns. That's kind of the reason why you want to work column by column. And then I'm just going to add negative 7 plus 7 becomes 0. Negative 8 plus 7 becomes negative 1. Okay. All right. Now, I also want to get a 0 here. I want to replace this 3 with a 0. And I can get that if I take row 2 and replace it with negative 3 times row 3. Okay, so I'm going to change my notes down here because I'm done with that row operation. So now I want 3 times row 3. So this is just going to become, this is just going to become 3 and 3. And I want to add that to row 2. Okay, so let's see. That becomes 0, 2, right? Because I've just got zeros below. So if I add row 3 to row 2, it's not going to change the first 2 elements. And then, actually I want minus 3, don't I? This should be minus 3. So I get 3 plus a negative 3 is 0, which is what I was going for. 7 minus 3 is a 4. Okay, and then I'm just going to leave the third row as is. All right, now I'm so close, right? I'm almost to my goal. And now you can see I can divide that row, that second row, by 2, or 1/2, take 1/2 of it, and I don't get any fractions, okay, which is nice. All right, so I just left that 2 there just to avoid the fractions. That was just my strategy. That's not a hard and fast rule, that's just my strategy. All right, so when I take 1/2 of row 2, I'm not touching the first row. This second row becomes 0, 1, 0, which is what I was going for, and then half of 4 is 2, and then I'm going to leave the last row alone as well. And there you go. I have done it. That's my goal, right? I was looking for this kind of a matrix, right? They call this reduced row form. But what that allows me to do is just, if I write that augmented matrix as a system of equations, I just end up with x equals minus 1, y equals 2, and z is equal to 1. Okay, so that's my solution. So down here where it's asking for my solution, I get negative 1, 2, and 1. Now, again, it's always a good idea to check. So I'm just going to take the original set of equations and plug in those x, y, and z values. And if I've got the correct solution, then I'm going to get true statements when I plug in x, y, and z. All right, so I can't get both of those on the same screen here, but the first equation is 2y, and my y value is 2, and then plus 3z, which is 1, and I want that to be 7. So let's see, is it 7? 2 times 2 is 4, plus 3 is 7, so that checks out. The next equation is 3 times x, so x is negative 1, plus 6 times y, y is 2, and then minus 12 times z, which is 1. I want that to be a negative 3. So let's check it. Does it work? Minus 3, and then I have a plus 12 and a minus 12. Okay, so the plus 12 minus 12 cancels out, and I just get negative 3. So perfect, that works. And then let's check the last equation. We have 5 times x, which is negative 1, minus 2 times y, which is 2, and then plus 2 times z, which is 1. And we want that to be a negative 7. So let's check and see if it is. So we have negative 5, and then minus 4, so that's a negative 9, and then plus 2 gives us negative 7. Perfect. It works. All right. So this stuff just takes practice. It really does. It takes practice to get good at it and to be able to do it without making little arithmetic errors. But so hopefully you'll have a chance to practice with the Wiley homework that's assigned, and the next two examples are word problems. So that's the only thing we have left, is just to look at a couple of word problems, and so that has the additional layer of setting up the equations to begin with and then solving them. So I will meet you in the next video for example 8.